Hi, we're going to continue looking at functions, and more specifically, we're going to look at the rates of change from one point to the next in a function. We previously looked at this when we were looking at linear equations, and we were calculating slope, and we quickly found that slope was the ratio of the change in the y, or the vertical, the rise or fall, over the change in x, or the run. If we have a data set and our points and we're plotting them, we can see that that's constant. We're going to see that we're going to create a line. And we did a lot of that in the past where we were looking at creating a line. But when I was originally having you work with slopes, I gave you 2 points, and then we calculated the slope and then connected the 2 points. Here I'm going to give you a set of points, more than just 2. But we're going to look at them and see if all of them together all fall on the same line. We're going to see if we can examine that and figure that out just by examining the points before we plot them. That way, in the future, when we don't have a handy-dandy little XY coordinate system, we'll have another strategy. Okay, so I'm going to look at this, and I'm going to go from one X to the next, and see if the change is, what the change is. Here I went from 2 to 4, so I added 2. Here I went from 4 to 6, I added 2. And here I went from 6 to 8, I added 2. So it looks pretty good so far. It looks like our change in x is pretty constant. Now let's check out the y's. I'm connecting them just to say the change from -2 to -1 looks like I added 1. From -1 to 0, I added 1 again. And I went from 0 to 1, I added 1 again. So that looks pretty consistent as well. The change from one point to the next is the same for both our change in x as our change in y. So we've calculated our slope right there. Our slope is the change in y, which I calculated up here. I went from y to y to y to y. That's 1. And my change in x, I went from 2 to 4 to 6 to 8. My change in x increased by 2. So my slope was 1/2. In other words, I have a rise of 1 and a run of 2. Now let's plot the points and see if that falls out. So plotting my points, I'm over 2, down 2, right here. Here I've got over 4, down 1. Here I'm over 6, 0. And here I'm off my chart, over 8 and 1. So you can see that, yeah, they fall along a pretty straight line there. So that all checks out. Okay, let's take a look at these points over here. When I connect my y's, well, actually, I'm going to do my x's first. So it looks like I'm going from -2 to -1 to 0 to 1 to 2. Looks like I added 1, added 1, added 1, added 1. It looks like all of my change in x is the same. When I do my change in y, from 5 to 2, it looks like I subtracted 3. From 2 to 1, I only subtracted 1 there. And then from 1 to 2, I added 1. And then from 2 to 5, I added 3. So I do not have a consistent change in my y's. Let's see what this picture looks like. So when I go to graph these points, -2 up 5 would be right here. And here I'm -1 up 2 would be right here. 0 up 1 would be right here. And then 1, 2, yeah, I got a definite curve going on here. It just whipped around and went the other direction, didn't it? Okay, so I can see that I do not have a straight line here, and when I look at this a little more closely, I can see that my slope from this point to this point looks like I'm down 3 and over 1, and from this point to this point, it's down 1 over 1. So we want to take a look at that a little more closely. I'm going to ask this question here. What is the average, I want to make sure that you understand that it's average, rate of change for these different intervals for when x is between, it's greater than 2 to 1, and from, say, 1 to 0, and even 0 to 1, and then again from 1 to 2. So on all these different intervals, things are changing. When x is 2, I'm right here, To get to 1, I went down 1, I'm sorry, down 3 and over 1. So that's a negative 3 over 1. That's the slope in that section. From this section, from a negative 1 to 0, when I'm moving x is negative 1 to 0, and from this range, it goes right in here. It looks like it's going negative 1 over 1. So what I'm doing is I'm kind of graphing this. This would probably come around like this and then up. It looks like I've got a curve going there. And so from 0, when x is 0 to x is 1, it looks like it went up 1 over 1. And then when x is 1 to x is 2, right here, looks like I went up 3 and over 1. So you kind of see this pattern of our slope. These are our slopes in each of those sections. Went from negative 3 to negative 1 to 1 to 3. Our slope kept changing. Our rate of change from one point to the next kept changing, and that's what created that curve. And we could tell that just by looking at this up here. We wouldn't have had to have graphed it, but graphing it kind of helps us make sense of it. So down here, I'm kind of doing the same thing here. I'm giving you more information, kind of putting it in print. That you calculate the change in x and y, and you want to check to see are the changes constant, meaning equal. So those constant changes indicate a straight line. Unequal changes indicate a curve. Okay, so looking at this first one, the work has kind of been done for us. Looks like the change in x is 3 from one point to the next. From one y variable to the next, it looks like our change is y. Okay, it is 1, I'm sorry. The other thing here is, in this case, I've presented the information to you in a chart. Up here, I presented the information in point notation. So you're seeing all different ways that relationships between numbers can be presented to you. Okay, back to this chart. I want you to recognize our change up here. This is change in x. In chemistry, a lot of times change, the difference between two numbers, is communicated with a triangle. And down here, this is change in y. I'm just kind of throwing that in there. So you recognize that if I was writing my slope would be the change in y, which goes in the numerator, over my change in x, which goes in the denominator. So this is my slope here, so of 1/3. So if I plotted these points, I'd be going negative 6, negative 2. So I'm reading my point by column here. So negative 6, down negative 2. This next one, I'd go back negative 3, down 1. The next one is 0, 0. It's right on the origin. This one's over 3, up 1. This one's over 6, up 2. So you can see that, yep, those fall on a straight line. That all jives. This is making sense. Okay, this next one, I'm going to do my little scoops out here so you can see that from one point to the next, x is increasing by 1 in each of these cases. So I could say we've got an increase of 1 from one point to the next. Our change is we've got a change of 1. So in our y's, what's going on here? It looks like I subtracted 3 to get from 6 to 3, and to get from 3 to 2, I subtracted 1. From get to 2 to 3, it looks like I added 1, something looking really similar to what we had up above. And then from 3 to 6, I added 3. So this is a difference. We have a change in our differences. So let's see what things look like when we plot this. So I go negative 2 up 6. That's going to be up here. Negative 1 up 3 will be right here. And then we have 0, 2. It looks like we have a very similar figure to what we had before. And in fact, these are called parabolas. It's a quadratic equation. At this point, you don't really care about that, but that is going to definitely produce a curve. So our rate of change is not constant. We're down 3 and over 1 again. Down 1 over 1. That's not constant at all. Okay, so let's check this next one out. Our change looks like all of our x's were adding 1. Our change between our two x values is 1. And going from one y value to the other, it looks like I added 4 here, going from negative 7 to 3. From negative 3 to 1, I added 4. From 1 to 5, I added 4. And from 5 to 9, I added 4. So if things are pretty constant there, we could assume that, yes, this is going to be a linear equation. My change in y is 4. That's in the numerator. My change in x is 1. So my slope would be 4, 1, so we know this is going to be a positive, up 4 over 1. So when I go to plot these, I've gone -2, down 7. I'm off my chart. We're going to say that it's down here. Okay, -1, -3, 0, 1, over 0, up 1, over, wait a minute, I'm reading my graph incorrectly, I was going the wrong direction, over 0, up 1, and over 1, up 5, and over 2, up, holy cow, 9, I'm way off. Okay, but I can see that I've got a line going here, and it's a pretty steep one. Okay, moving on to the next section, just really quickly, we can take a look at, behavior of our y variable based upon our x variable. So when we look at each of these graphs, we can kind of identify whether or not, first of all, whether the function is a linear function or non-linear. You can definitely look at, is there a curve or not a curve? If the graph is linear, we want to identify whether it has a positive or negative slope, whether it's, rising going left to right or falling going left to right. And if it's non-linear, a lot of times we describe that relationship as increasing or decreasing. So I kind of wrote these in here just to make sure that we didn't run out of time on our video. But our first one, obviously, that's going to be non-linear, and it's increasing going left to right. The next one, clearly we can see we've got a linear function here, and it's got a negative slope. This one is non-linear, there's a curve there, but it's decreasing as x moves to the right. As our figure moves to the right here, x is increasing, but y is decreasing. And here again we have a linear and we've got a positive slope. So just recognizing and some things that we can get off of that information.